Hey, welcome back. I want to talk about some more code art. I'm going to use shaders and apply a material to a bunch of meshes in the scene and create something that looks like this. Let's get started. What I've got is a very basic boilerplate scene for THREE.js where I'm instantiating a box. Let's change that to an icosahedron and passing in a size and a complexity. Let's just say const size is equal to 1.0. And can't really see it, but it's actually an icosahedron now, which is normal material. Instead, okay. Instead of calling it cube, let's call it mesh. Great. I'm going to take this icosahedron, which is spinning in the middle of my scene, and I'm going to create a bunch of them in a row, and then duplicate the rows so that we have a grid of those. Okay. I'm going to create a for loop. Define equals 0 while I is less than let's call it grid size. Grid size I plus equals 1. And inside it, well, let's just const grid size equals 3 to start with. Yeah. Inside of here, let's say let box equal get box. Okay. And boxes dot push box scene dot add boxes. Oops. Like that. There's a couple things that I didn't define yet, and that is this const boxes is equal to an empty array, and this get box method, which is going to be wrapping this function get box. Whoops. And instead of this last line of this method being scene.add, let's just return that mesh instead. I broke it. Can you guess why? Can I guess why I broke it? Grid size is defined on a box, get box, boxes, scene.add boxes. Oh, mesh is no longer here. Let's cut this out, and I think I unbroke it, but I don't see that add box. That's what I meant to do. Good. Right now, all of those boxes are stacked upon one another. Mesh dot rotation dot x equals math dot random, and this will spin around so you can see them. Function update. This will currently I'm creating 3 boxes. And I'm adding to the scene. I'm calling this method get box, which is just returning a mesh. Why don't we encapsulate this behavior as well as the data in the return of this method? A simple JavaScript object, and it has the mesh and its update method. And I'll just change this to mesh and save it. Whoops, I didn't mean to do that. I did it backwards. Scene.add box.mesh. Now I can say boxes.for each b.update. And voila, all the boxes are spinning together. Math.random is my friend times, now they all spin slightly out of sync. I see them kind of diverging. Isn't that cool? Math.random times 0.02. Oh, wow, that's really cool. I didn't expect that to like that as much as I like it. By the way, I think another cool kind of prototyping material is a depth material. Oh, it's not very clear though. It's really faint, so I'm gonna undo that. I like the way those diverge. Anyway, back to the task at hand, which is creating a row of these guys. To do that, I want to give each box a position. So let's define what that position is. Let position or pos equal a simple JavaScript object with an X property and a Y property. Okay, and then up here I'm going to accept that into this as an argument in this method, and each mesh dot position dot x equals pos dot x, and I'm holding down shift and option and down arrow on my Mac keyboard to just duplicate that line like so. It's exactly the same because x and y are the same, but what if I said x is equal to I? Now they're all spread out like that. I don't like the way they start in the middle of the screen and slide off, so let's offset the boxes. Oh, they're not boxes. Why am I calling them boxes? That's unfortunate, isn't it? So let's just change that to balls. I think they're balls. Ball. There. There. Okay, now they're balls. And the scene is broken. What? Oh, get ball. Like that? Okay, good. I want to offset them. So const start pos equals. Another way to, instead of creating a simple JavaScript object with two properties, an x and a y, I could say a new three.vector2, and that's the same thing. And the handy thing about using a vector2 instead of just a simple JavaScript object is it'll give you methods that you can use on that data, on the vector. But I'll just leave it for now. The x will be -1 and the y will be 0. And I want to add that. See start pos.x plus I. So that's going to scooch everything over. This feels like a little bit too much for me for right now. I'm just going to return to simple JavaScript object and scoot it over a little bit more. And that works just the same. Okay. I don't like the way they overlap, so let's scale them down slightly. Slightly more. Good, now they're not overlapping. In fact, that's all I'm going to do for now. Let's make it 5 instead. Great. They almost look centered up. Let's duplicate this row. I should have called this X, X, and X. Okay. And that still works. Good. Now duplicate this line. Shift, option, down arrow. And change these to Y's. Okay. And now, Nothing happens because they're all just sitting on top of each other. Wow, isn't that cool? The boxes, the icosahedrons kind of mutate. I like that. Okay, let's change this to start pos.y plus y. Oh, look at that. And start pos will be scooted down. And isn't that nice? Great. The next thing I want to do is to apply that cool shader that I created. Here's a look at the shader. It's kind of smooshed. So this shader is doing that. I'm going to have to create another video to discuss the creation of this shader. So let's go back to our THREE.js code and focus on that instead. But stay tuned for that. Let's swap out. In fact, we don't need these declarations inside the method. We're using the same one every time. Let's move those outside of the getBall method, and it breaks everything because I need size out as well, which is too bad. I like having size in there. That's okay. I can do that. I can let's say 1 here. Great. And then here I can say the mesh dot scale dot set scalar, and then pass in size. It's the same difference. Good. We've got to do some refactoring now. In order to use these shaders, I need to load those shaders into our scene. Currently, they're not in the same file. I could just copy and paste them into this index.js file, and I wouldn't need to load them, but I really like having them in a separate file. It's much easier to work with for me. So let's refactor the code so that when this runs, when we load the script up, it'll go and fetch those shaders and then use the data to shade our boxes, our balls rather. We'll load the shaders at runtime, use that data to shade our balls. Okay, here's how I want to do that. I'm going to wrap all of the kind of code we've written so far, except for the boilerplate. I don't want that. We're going to wrap it in a function main, because it doesn't matter what it's called. And I'll just select everything we just written, including the animate method, scooch it over and a client close, and then we're going to call it like that. So it still works. I just wrapped it in a method that gets called. And this method is going to load up the vertex shader and the fragment shader. Create sh equals fetch, and then the name of the file, which is, in quotes, it's called vertex.glsl. Okay, and duplicate that line, typos and all, and fetch the fragment shader, which is called frag.glsl, and this is actually called vert. Okay, save it, and it should work. Here's the thing though, it's going to take some time. So if I console.log the fragment shader, that's the one I'm really interested in, although I need them both. I think what I'll see is a promise that's been fulfilled, but it's not immediately available like I want it to be. In order to use it, to apply this as a shader, I want it to be available. It's not available yet. Text is the method to call to get the contents of it. And what's it saying here? It's saying it's not a function. Why not? Because it's not loaded yet, I think. So to handle this, we're going to do some asynchronous stuff. Let's say it was console. What did I just have here? I'm doing it there. We're going to await the result of this fetch. Await and await. We can't use the await keyword in a regular function. We have to change this to an async function. Okay. Now, if I were to save this and it automatically loads again, now I see, look at this logout. There's that file. This is the text of my file. Comments and all. So, just to recap what I just did, I wrapped all of our code in a function, and I gave it the keyword async to tell the JavaScript engine this is an asynchronous function. Then I awaited the results of these fetches and this text call to get that shader. The next thing to do is to apply this shader to, let's duplicate this line. Actually, no, we don't need to duplicate it. I'm just going to change this to a shader material. And we're going to pass in options to this. Actually, you don't need to pass in options. We'll just paste them right in here. And it needs uniforms. I'll explain in a second. It needs a vertex shader. That which I'll define in a second. And it needs a fragment shader. Okay. The vertex shader, we already know what the fragment shader is. It's this. And then the vertex shader is just the PSH. Let's see how we're doing with this so far. See if it's still compiling. There's an error because uniforms is not defined. Let's define uniforms. Const uniforms. Let's tidy up that indentation. Is equal to a plain old JavaScript object, but it has whatever properties we want to pass to the shader from this program, from this JavaScript program. In this case, all I'm passing in is this time property, and it's got a value of 0. Okay, now I have uniforms, and we have our shader just like that. How cool is that? It's not quite looking like the demo I showed a second ago, like this, but we're getting there. How cool is that? That I love that when it just works. Let's update this value for time. Let's update it in our animate method. Let's say uniforms dot time dot value equals t. We don't have a t yet, but let's pass in, let's get a t here. And let's also t times equals 0.001. Let's slow it down a little bit. Okay. Now we see that these beautiful rainbows kind of moving around in the shader, and that's because we passed it this time value, which it's using here. So now the next part is really obvious and easy. We're just going to smooth out that icosahedron. Let's give it 3 detail instead. Now it's nice and round. Maybe even let's make it super round with 6. Aren't those pretty? They're a little bit too big. And there's a little bit more space in between each one of them now, so I shrunk them down. Also, this rotation isn't quite working for me. We have these patterns that emerge, that kind of like flowing water or lava or something like that. To get that, instead of this kind of randomness, In fact, let's just change them all to uniform now. Now they all rotate together. To get that, let's pass in addition to that pause, let's pass an index, which will be the x value plus the y value. So each one of these objects gets its own index, a unique index. And we just need to deconstruct those here, like so. And we're still happy, it's still good. And then I'll create an offset variable, const offset. For each of the balls, they have an offset variable, which will be the index value times 0.1. So let's reduce it. And then add that offset, like that. And it's a little bit fast. A little bit too fast. Let's shrink it by half. And still, that's still pretty cool. Right? And if we want to see more, we can increase the number of spheres, and I want them to be closer together first, and I want them to be smaller so they all fit on the screen. Let's move them closer together first. We'll create a const gap variable, and we'll make that 0.5. And now we're gonna multiply times gap. That should kind of hug them together a little bit more. Same here, times gap. Now they're all kind of nestled together, and look at the way they're all overlapping. Creates an interesting texture.
This side.
It's also pretty frenetic and fast. Let's slow it down a lot. That's twice as slow. And let's slow it down even more. Oh, isn't that pretty? Okay. Well, I was going to shrink these balls down a little bit so that we have a little bit of space in between them. I think 0.25 should do it. Yeah, that's about right. Yeah. In the next video, I'm going to discuss the shader in detail. That's a whole video in itself. There's a lot to go over here. And I'll also point out that you can do some fun things like change the hues to all one hue, for example, and shift that around.
Down again. This is
Make it green. And get some cool effects that way. But that's for next time. Thanks so much. Please leave your comments below with any questions or comments or suggestions. Love to hear them. And thanks so much. See you next time.